Hello everyone. We are back with our next installment of system design videos, and I am sure that all of you are doing extremely well. Welcome to this video, and in this video, we are going to tackle a very challenging problem of how the fantasy sports app is being designed and how they actually uh, scale to that millions of users per seconds in that rate, how exactly that is being done with multiple multiple matches going at the same time. So that is something, a very interesting problem that we are going to tackle today. And first of all, before going into this uh, uh, particular system design, a big disclaimer that never ever put your money on these apps if you want to take my opinion, as I get so many number of messages like sometime back in my some years back in my WhatsApp, that few of the juniors, they were telling me, bhaiya, I lost some money on Dream 11. Now how do I tell my parents? They were just college students. So always try to avoid this kind of fantasy sports app. They are engineered in a way that you never really win any tangible amount. Like if you see the total, if you see the total mathematics or the probability. But anyway, let's jump on to the actual point of discussion today. So Dream 11 is a fantasy sports app platform. So what does fantasy sports app does is, like, this systems are nothing but where user can uh, put their money on multiple matches and select their own team. Like they can create their own team with the real players and earn points as the live match goes forward. Okay. Yeah, so just to make it further more simplified, you can see, like, I just wrote the definition, or just what exactly those fantasy sports app are. Like their user can create their virtual teams with real players for a real match and earn points based on the match events. So on a hindsight, if you see, no matter how addictive or bad these games are, but technically these are kind of a state of the art system which handles huge scale and super reliable, as it deals with monetary transactions. And during, like, one of the documented thing is that, like, during IPL 2023, okay, so I found it somewhere while researching about this video. Dream 11, it processed 2.5 million events per minute. Okay, 2.5 million events per minute, and which like roughly around 42k events per second, and which is a great scale. Like if your database or your system is able to handle this much amount of scale with monetary transactional reliability, that is one of the main part. Like it is completely handling lot of monetary data as well, right? So if it can handle the monetary transaction reliability, that is really one of the really one of the achievement, I would say, in terms of the engineering. Anyway, now coming to this fantasy sports app. In this particular app, what are the other components are there? So other than the each user's individual points, there is something called leaderboards as well. So leaderboard is a dynamic array of boards or array of scores, which is depend on the live matches. So when a cricket match is happening, okay, for when a cricket match, so during cricket match, every run or wicket taken by a player, every run or the wicket taken by a player, that will be that will uh, corresponds to some kind of a point. So suppose like let's take example of Virat Kohli. Okay, so Virat Kohli is taking like scoring 20 runs, and there is like Mumbai Indians versus RCB match is going on, and also there is Bumrah is there, and Bumrah is scoring like 3 wickets. So each 20 runs correspond to 1 point. So Virat Kohli will get 1 point, and as Bumrah got 3 wicket, probably each wicket can be of 2 points or 1.5 points. So Bumrah might get 4.5 points in total. Okay, so 1 point, and this can be 4.5 points, something like that. Okay, and this means that system has to handle this massive influx of data update during the live matches. Now, why is it so? Now let's think around that. So this is kind of a system which deals with a burst in a moment. Like suppose there is like some 20 million users are there. Okay, some 20 million users, and all of them has subscribed, or all of them has added Virat Kohli in their team. So in case Virat Kohli reaches that 20 runs, all of that 20 million users has to be updated. Okay, so let's make it a little bit more formalized in a way. So when a cricket, one of the challenges that system of this system we can very easily identify, like the user won't use this system all over the day. So this is the first point. User won't use this system in consistent basis. In consistent basis, rather they will use it only during match. Only during match, or maybe like some plus minus like 2 hours or 4 hours time window, when user can actually create their team during their match, or maybe minus 4 hours, maybe minus 4 hours time window, something like that. This application will be used. So I think this is pretty much clear. Okay, now what they will see is, now what user will experience is, suppose there are like 20 million users, they all have added one player. When that player takes a wicket, all of the users scores to be updated. Yeah, so this is one of the very interesting thing here. So like now, uh, now let's just formalize what are the points, or what are the things that these points are being calculated on. So this is just for our knowledge. We will not need it in our video a lot, but still let's formalize it so that we can so that our concepts is completely clear. So number of runs, wickets, the maiden overs taken by a bowler, catches, and also strike rate is very important, like a certain run scored in a certain strike rate. This all correspond to point. Okay, this all correspond to point. So as you can see here, this is a very complex aggregations are going on. Now what exactly is happening over here is, if you see, so user score is to be updated. Okay, user scores are to be updated, and also as we were discussing earlier, like there is a leaderboard. So what exactly is a leaderboard? That during cricket match, yeah, sorry, yeah, the leaderboard, I think I should have gone a little bit more details. Among all the users who is top 10 or top k, suppose. Okay, so among all the users who is the top 10, so whatever the data or the points that we will have, right? So suppose there is a cricket match is going on. This is again very high level I am discussing. We will come to the details very soon. Suppose a cricket match is going on, and from this match, this leaderboard to be updated, and also this user score to be updated. Okay, so both of these things to be updated for sure. This leaderboard will be nothing but like something like top k users for a given match, and this users is like a individual user score. Okay, so um, now let's start with our actual design, how it would look like. So I would like probe you to just wait for like just give yourself like 10-20 minutes and try to find out how exactly you are going to design this system from scratch. If you have to design it like suppose in a meeting suddenly this kind of system came up, and if you have to design it on the fly, how we will do it. So I would request you to take a pause and try that. Okay, so now let's discuss how exactly these streams are to be processed. Okay, so on a very high level, what is happening is there is a match going on, right? So there is this match going on. So in this match, there are a lot of match events are getting created. Okay, so suppose how events will be created. Suppose in a single over, somebody is taking a wicket and also they are winning the match at that same time. So there can be array of events can come, like wicket for a given wicket by a given bowler, and plus catch by a given plus catch by uh, suppose by a given player. So wicket by Bumrah, and suppose there is a catch by Rohit. Okay, so both Bumrah and Rohit, their their point needs to be updated, and gradually all the users who have Bumrah or Rohit in their team, they need to be updated as well. So what will happen is, here if I see, it will emit a match point event, not one, actually two match point event it will emit. And how the match point event would look like? Match point event would look like something like that. Like if I just have to put it, so yeah, you can ignore this Kohli part. Instead of that, it can be Bumrah and Rohit. Okay, or let me just write it here. Suppose Bumrah is there. Okay, and also for Rohit. So two events will get emitted like this, and then what will happen is, this event needs to be passed to some kind of a stream processor. Okay, and that stream processor, what it will do is like, so this stream processor, what it will do is, it will then fan out to all the users. Okay, suppose user 1, user 2, and whatnot, like all the users that have Bumrah or Rohit in their team, it will get fan out to all the users. So if you are unaware of what fan out is nothing but like you have a single event and it is getting like how a fan works, right? Like the its air keep on spreading into the all direction in the room. So it will be, that particular event will be uh, sent across to all the given subscriber of that particular stream or the event. Okay, and also alongside that we have to prepare the leaderboard as well. So this is the like update the user scores, and alongside that it will, what it will do is it will update the leaderboard as well. So this is not at all the system design. What I'm right now doing is just acclimatizing you with what are the things that this system does. So before that we will just before coming into the actual components around the system, let's take up another small exercise which will get uh, which will get our position a little bit more stronghold in terms of our concepts. So let's try to design all the API endpoints. Okay, all the API endpoints for the system. So suppose just imagine that I already have a database. Okay, I'm not complicating the matter much. So just think that I already have one database. We will of course later on discuss like what kind of database we are talking about. So from the database, I want to query and get my scores. So how do I get my um, my score for the current match? So how it will look like is, suppose the v1 is the my API. I can have this course, and as there will be multiple matches, so I can pass probably something like a match ID and the user ID combination. So match ID and the user ID combination. So that will give me the actual score for this particular match. Okay, so this will what it will do is it will suppose um, give me the actual score for the user. Like suppose this is the user's device. In the user device, it will give the user's actual score will come. Okay, now we can further break down into multiple things. Like in our database, there is one more very important endpoint is like while the user is creating the match, that will be basically update team. So update team will be again in terms of API, it is going to be really simple. So what it will have is it is going to have match ID and user ID, and the payload will be the whole like let me make it more clear. Yeah, so the payload will be maybe a JSON with the whole team's structure, and there can be one more. Of course, there has to be one more, that is for the leaderboard. And leaderboard, as you know, like leaderboard will only return. It is just a top K. So there will be like V1. Yeah. So this and this will be post, and probably this can be a get. So V1 like get leaderboard. Okay, something like that. Get leaderboard, and of course, yeah, the match ID I need to pass, that is important. So leaderboard of the match ID. So this can be get, or you can make it a post as well. So this is how this data will keep on traveling to the user's device. Okay, so now let's start discussing about this database now. Okay, so now that we have a fairly good idea that what will be our data, uh, what will be our data points, let's try to think what will be our data store. And trust me guys, the moment we figure out what exactly what kind of storage engine we are going to use, that will make 90% of the 90% clarity around our system, that what will be our components and how exactly our system would design. So let's discuss around it. Let's discuss about the storage engine for Dream11. Okay, so let's discuss around storage engine for Dream11. Now the so far whatever the idea that we got is, there is a stream processor, and this stream processor will fan out the data to all these users. And additionally, we are also going to have like a leaderboard. So of course all this data has to be stored in some kind of a storage as well. It can be what kind of storage it is, we will now we will discuss around it. So at first let's think around it. So in any day one architecture, we always think whether RDBMS is an option or not. So by default, any system that we try to design, RDBMS should be the first choice. So let's see whether RDBMS actually serves purpose or not. Okay, so the first thing that we have is there will be a match events. There will be a match events table. What it will have is it will have match event ID. Like if I have to mark it, okay. So this is the table, and these are the columns. So it is going to have match event ID. Then it is going to have player ID. Then it is going to have the details like run or wicket, catch, and a timestamp as well. Okay, so this is one of the important table, and another table that we are going to need is like here we have the this player ID is not the actual user ID. This is basically which player I have, which uh, player I have actually is player is actually scoring the run or taking the wicket. So there also has to be one more table for like the user team, something like that. So which like here it will be like the user ID, match ID, and all his like it can be a list of player IDs, something like that, or something like e- 11 players, like for 11 players or the impact players and everything I have marked, like I can have 11 columns as well. But again we will uh, try to come there, like whether this is actually necessary or not. Other than that, there will be a user score aggregation table, because if I every single time I have to query all the data, that is a problematic thing, right? So this is going to be a aggregation table sort of a thing. So once all the data are being inserted into the match events, it might probably our stream processor will do the honor of updating this table as well. So as you can see, like this is how a few very necessary tables will be there. Now just think, the sheer 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 scale of 10 million users. Okay, so the 10 million users have created a team which has Virat Kohli. Okay, on a given day, on a given match day. Now the match is going on. So what will happen is, for the RDBMS database, 10 million row update in a single second. So in RDBMS, 10 million row update in the match events table will happen. And each update of RDBMS, as we know, like if I this is not a DBMS internals, but each update do a row level locking. Okay, and what it does is it can lead to contention, and it can lead to some kind of a momentarily deadlock as well, although these days RDBMS systems are quite good in detecting deadlocks and resolving them, but still there is always a risk to that. So this would be with this row level locks and deadlocks. Okay, this thing will be a, if I have to just give, this thing will be a maintenance, like, or rather a scaling nightmare. Okay, it's going to be a scaling nightmare. Also there is a aspect of, on the aspect of leaderboard, as you can see, like after each match event I have to hit the user score table to get the top K. So you can see like again and again from all the users this kind of query will come and our database will be overloaded. So the kind of a like write per second WPS or the query per second QPS or the read per seconds also you can say, it is that we are seeing over here is it is too difficult for a RDBMS to handle. And also the burst traffic is something that we always need to keep in mind while designing this system. So uh, the leaderboard in terms of the leaderboard or in terms of the match event score, we could understand that how difficult it would be for a RDBMS system to scale and work over here. Okay, so uh, what are the scaling nightmares? Let's discuss again. So 10 million row update in a single go, that is one of the problem. And also we have written these two things, this row level and deadlock, that is one of the problem. And the other problem is this aspect of leaderboard, that is the leaderboard recalculation again and again. Okay, now how do we handle this? How do we handle this problem? Okay, so when Kohli scores, we need to update all the users who have him in his team, right? So that exactly is our problem statement. And because the number of users are too high and like we won't be able to update the database in that frequent manner, so that is a kind of a problem that we are having in hand. So if you see in a single second as the database is getting updated, so if we are updating it in synchronous manner, now this is the one of the key thing, if we are updating in synchronous manner, even a NoSQL partition NoSQL rather I can write partitioned NoSQL like Cassandra, then also this is going to cause a lot of problem. So if you are thinking that let's introduce something like a message queue and try to see how we can influence the fan out and make it is a async process, then you are going into a right direction. So our correct direction is, the first step to the correct direction is making this update async. And not only our database, there will be other analytical service and other archival service will also be there which will be looking at this data. So the correct direction would be to make this update async. Okay, so suppose now I have this Cassandra schema. So let me just write the Cassandra schema here. I'm just copy pasting it for the convenience purpose. So as you can see here we have this user teams. Okay, so Cassandra, I would like to bring your attention to this point about this partition scan. Okay, so what Cassandra gives you is a partition wise a very fast scan. So when we are having a user team sort of a thing like the match id players, so match id can be like mi versus rcb ipl dash 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 whatever, and the player id will be Kohli. We can find that all the users to whom we have to fan out. So just look into this particular part a little more carefully. So what it is trying to determine is, it is trying to determine that this query is meant to determine which all user have Kohli in their team, or any match event that comes for a player. This query can determine which will be the users who have added that player. Okay, as simple as this. Now alongside this, we also need to understand some very important aspect of it. Okay, so now what exactly is the design? Let's try to draw like our match source and everything. Okay, so here I have a match source of mine, match event. Okay, what this match event will do is probably via some http or some webhook, http or webhook, it will send all the details to a game service. Okay, it will send all the details to a game service, and what this game service will do is this game service will then send this data to our Kafka. So as we just discussed that um, we need to make our update async. So how do we make our update async? So the first and foremost thing that we should or we can introduce is our Kafka layer. Okay, so what we are going to introduce here is this Apache Kafka. Okay, now a very interesting thing would start happening. What this Kafka will do from here? So there will be multiple things, right? There can be something like a push notification service, like the user, just for your uh, um, marketing purposes or like user awareness purposes, you keep on sending all this data to your user's device. Okay, so you take the push notifications and send it to the user's device. The same Kafka, what it can do is it can have another topic for its analytical engine. Additionally, it will also have something like or the core of our system, that is the stream processor. What this stream processor would do? This stream processor would do would basically put the data to our data store, and also like put the data to a data store, and also probably it can help us in the like leaderboard calculation as well. So we are dividing this system in a very phased manner, I would say. I'm not introducing even the actual database right now. I just want you to be very clear around it, that Apache Kafka, what it will do is through different topics, it will divide the data to the push notification service, to the analytical engine or the stream processor, and then this stream processor, which will get the match events, what it will do is it can take it to the data store. From that data store we can think of creating the user scores and the leaderboard calculation. Everything the stream processor can influence. Anyway, now let's discuss around this part. Okay, this stream processor is actually one of the like the core of our application. Okay, so why I'm telling that this is the core of the application, we will just uh, understand in few moments. So now that we understand that there is a Kafka or a messaging that is required, and now we also see that there is a stream processor sort of a thing required. So just think, what is this stream processor? So suppose, think about a simple consumer. Okay, so what this consumer is doing is this consumer is getting the data from Apache Kafka. Okay, now you can understand how throughputy that, like how high throughput this Apache Kafka can be. Like there can be so many events might get created, and that stream processor has to consume all of them. So for a very high throughput and a calculation intensive data, so here the throughput might not be that g- grave of a problem, but the problem is there will be lot of processing required, okay, on this data. So what kind of processing? So once a match event comes, this consumer has to go to DB to get the details of the number of subscriber users for that event or player, I would say. Okay, and then some aggregation will might also be required in case I want to influence my leaderboard calculation as well, because suppose I'm just I just keep on entering the data into my data store. Again, some kind of event I need to raise, and then I need to calculate the leaderboard. Whereas if I can actually influence the leaderboard calculation via my consumer, then it will be a near real-time leaderboard. Okay, so uh, if we require some kind of a data processing, aggregation, or additional join, etc. So this will be a simple consumer model. A simple consumer model can be very finicky. When I say finicky, means like it can make or break your things. Okay, and the main and another main problem is like make it a distributed. Make it in a distributed manner is again a challenge. So this is currently is a single threaded consumer. This is currently is a single threaded consumer. Okay, and scaling horizontally, this particular consumer requires a uh, lot of lift and shift around the system. So uh, instead of this kind of a consumer system, what we are going to do is we are going to use something called Apache Flink. Now those who are coming from a data engineering background, Apache Flink is like probably in one of their bread and butter tools, but let's talk a little bit around the Apache Flink as well. Okay, so what Flink does is it will be able to take the consume the event, okay, and even like even the it can it can handle out of order events. So Apache Flink is designed with all of these things. I'm not going into the internals of Apache Flink, but just try to understand that when a user score update like uh, Rohit Sharma scoring 20 extra run. So at 3 p.m. it arrives, and at it arrives in the main Apache Kafka queue. Okay, but later we find that it is coming into my Apache Flink at 3.02 due to network latency. It can Apache Flink can handle it very well. There is no it has event times semantics to process event based on their actual occurrence time. Okay, so it can handle the late data with watermarks and windows very well. So that is one of the main advantage that we get, and the other advantages are like scale. This is meant for scale across across multiple clusters, and auto scaling and the parallelism is also one of the features. So uh, of course the auto scaling is there, and as I was talking about, like when we are writing our consumer, that is being a single threaded consumer, but this is kind of a parallel. This kind of supports parallelism out of the box. Okay, and it reads player events. For each events it queries Cassandra. So now let's go a little bit detail around it. Okay, so what I will do is I will just take this Kafka. So we are clear till this point, right, that we are sending the data to Kafka. We will just concentrate on our Flink job right now. So from Kafka, the data come to our Flink job. So from Kafka, the data comes to our Flink job. And what will happen from here? From this Flink job, there will be, what this Flink job will do is, it will at first go to Apache Cassandra. Okay, so it will go to, let me take the database icon here. So it will go to, instead of database, let me write Cassandra directly, as we kind of established that we are going to have a NoSQL database. So from Cassandra, what it will get is, for a given event, which are the subscriber players. Now, it may be in the Cassandra or somewhere else only, after processing this data, it will update the user score. So where it will update and how it will update, we will again come in a little bit more detail. We will break the system in very granular manner, so we understand every single details. So as you can see, now user score will be updated to Cassandra. Okay, now user device will have the user score for sure. Now once the user score is actually prepared, what we are ready to have is, we can have our leaderboard ready. Now once, like, let me write it in this way, once all the user score is updated, we can calculate the leaderboard. So you can see this thing. The advantage of having Apache Flink is, all this thing can be done under the same job. Okay, so this Flink job, it can actually take care of every single thing, and in a parallelized way. So when this user score update is getting happening, this update can happen in a complete parallel way by saving a lot of time. Okay, so now you can probably understand the power of Apache Flink. And this will be like, it will calculate new scores and emit all the user score update details. So this can be again like some kind of a user score update event. Okay, it can be some kind of a user score update event. uh, and this is where the actual fan out is happening, and this is happening in a parallel way. Let me emphasize it again and again. You see how many times I have written the parallel, just to emphasize this point, that when a user score is getting updated by Flink job, it can emit or it can update the Apache Cassandra in a parallelized, completely parallelized way. Okay, and all this thing can be, I mean, we can even take this whole part out from this. For example, all this thing that we have here, like the Cassandra or all this data. Okay, so what we can try to do is, I don't know why it is happening like this here, strange. I will delete it anyway. So user score update event. Okay, so what we can do is, we can take all of this thing part out of our Flink job. Like Flink job will only do this part as per our convenient, and it will just emit the event, and the rest of the thing will be in our control. Okay, so that also we can do. So this is like our own implementation as per we need. But let's understand one more intricacy over here. Okay, that is where exactly we are going to store this immediate match data. Now, as you can see, one of the fact over here is the Flink job here. Where should we store our live match data? This is a very interesting thing, guys. This is a very interesting burning question. Where should we actually store all our live match data? So probably you understand one thing, that the match data has only importance during the match, right? We do not even have to, like, how likely it is the case that suppose user have like when I say user, the uh, a person who is creating the team, a person is creating a team in IPL 2024. How likely that he is actually going to access that team in next IPL, or even in the 24, suppose it is on 17th of April, there is a match. It is very unlikely that he will even access his data on 20th of April, because it is kind of a day by day basis and people do it out of their impulsive addiction. Okay, so the 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 key takeaway from this is we can store in a very fast retrieval storage like transient storage like Redis. So what we can do is, instead of using Cassandra, what we can do over here is, I will just try to refine our like architecture again a little bit more. So here we have, like, I will just to save our time a little bit, game service till Apache Kafka I will copy here. So we have match events and our Apache we are publishing all our match events to Apache Kafka, and after it is coming to Apache Kafka, what it is doing is it is going to send across in different uh, engines, like it can be analytical engine. I am not writing all of this thing together, but let's talk about the stream processor. Okay, so then it comes to the stream processor service, and this stream processor is nothing but this stream processor is nothing but Apache Flink job. It is a Apache Flink job, and what that Apache Flink job will do is it will fetch the user from DB, or rather I would write storage, because we already have mentioned Redis, and probably I was able to convince you that because this is a transient, not exactly transient, but a very fast retrieval is required. So we can store our data, our match related data on that very moment for a live match into our Redis. So we can have a, like a Redis database over here, and what that Redis database will do is, I will just bring a Redis over here. So this Redis will have whichever the user have opted for that particular match. So suppose there is a match of RCB versus MI is going on. Okay, suppose this is the key for that RCB versus MI in our IPL 2026, suppose. Okay, and what it will have is it will have the user and the player collection to it. So the moment I try to query, like fetch the user from the storage, like once it gets the match event, it will be able to see what are the user that should be updated. Okay, now what it will do is it will again like in the same Redis, yeah. So in the same Redis, what it will do is it will store the user scores. Okay, it will store the user, it will calculate and score the user scores. So user scores will be nothing but like a simple increment, right? So if I see that okay, there is a match event which involves the user, so whichever the point will come, it will be increment on that user score. So my user score for that particular match will always be ready. So the key will be probably the match id and the user match id and the user id, and whatever the point that will come over here, that user score will be simple increment. Like if it is 1 point, it is 1. If it is like 2 point, it is plus 2, something like that. And alongside that, once this is getting created, we can very easily query Redis. There are some designated query, I will come to that. I will just write those queries for you so that in case you are designing anything like this, that becomes helpful for you. So what we will going to have is another Redis, within this another key value pairs, which will determine the top k. So whatever the data that I am going to have over here, okay, so there is a lot of data is there, and out of this data, what I am going to calculate is in Redis a top k data. And the main advantage of this thing is it is going to be a like even less than a linear time calculation on this. So that is how Redis is being designed as well. So for this we are going to use the sorted set in Redis. Okay, just remember this thing. Let me write it over here. To make this very performant, we are going to use Redis, a particular data structure within Redis, that is Redis sorted sets. Okay, now let's talk about how those Redis queries would look like. This is not very important, but still it will be a little interesting for you. Like you can have something like this leaderboard, mi versus rcb match. Suppose mi versus rcb, and suppose there is a given user 123, and you can just add some point, like add 20 points to it, and whatever the new point, it will be created. Okay, so using zadd like this, and this is how we will keep on adding it to our leader. This is how we are going to add it in our leaderboard, and each score can also be updated using zincrby. Okay, um, Zincbry or something you can call it. So I'm just writing those things for you. You can study. If I have to, it is for individual update, and this was for leaderboard update. Okay, and then it is like um, z rev range, that is for top 10. That is we are going to use for top 10, and it will give you the top 10 in basically o login time. Okay, so it is how it is giving, it is because of that sorted set that we are using in Redis. It will be able to do it because of that. And also there will be like if I have to find the user rank, it is going to be o1. We are going to use z rev rank. Okay, so z rev rank for user rank. Again, you can even skip this part, like this is not very important in terms of the system design perspective. When you go to the Redis documentation, you will find out, but still, just to keep you a little bit of literate around how Redis works, or how Redis sorted sets or the SS table works, I am adding all these details. Okay, so also one more thing, like Redis might run into, because they are like, if in a single day or in a single time window multiple matches are going on, Redis might run into a hot partition issue. So in a single partition there can be so many events and stuffs like that. So in that case, the idea is we have to keep it sharded very carefully, like across our Redis cluster. So now let's conclude the actual design that we have been discussing so far. Okay, so um, I will just start from here and try to write it. There is a cricket match that is going on, and that cricket match, what it is going to do is it is going to emit some live events. The live events that it will emit, what it will do is it will come to suppose any custom service, let's name it as a game service. Then what it is going to do is it is going to push that game service to our Apache Kafka. So how would the Kafka look like? I will just bring the Apache Kafka here, and from the Apache Kafka, what will happen is one thing will go into various storage. Okay, it can be like the moment this stream is coming, the moment its stream is coming, it can be like archival, or it can be like raw event storage, etc. And it can be something like in Cassandra, we can store it. Okay, Cassandra is the type of the DB. Other than that, the most important part, like let me just even change the color so that we all are like aware that something else is happening over here. So now what will happen now onwards is this is the archival and stuff are happening. Now the important part of our real-time leaderboard and the user score generation will happen. So there will be like a Flink stream generator or processor, I would say. Okay, so Flink stream processor will be there. What this processor will do is query user with players. Okay, so the Cassandra is already there, so it will go to Cassandra and it will come back from there. So let me just write that database as well. So suppose this database is there. Okay, and what it will do is it will go to the database and come back with the data. Okay, so what it will have at that point of time is it is going to have player info to whom data to be pushed. Now from here we are going to use Redis. All right, why Redis? We just discussed. So because we do not need like a permanent, we rather need a very fast retrieval at this point of time. That is why where we are going to use Redis here. So what it will do is it will update the user scores, all this queries that we just discussed, right? So what it will do over there is it will update user score 1. Then what it will do is it will update um, the leaderboard, or it will just create the leaderboard by emitting some events. So Redis also have this feature. What it can do is it can emit event after every calculation or every write. So it can emit an event and it can update the leaderboard and it can push the changes. And also additionally what it can do is this it can top k create that top 10 or top k, and after that what it can do is it can emit events. After all these things are done, it can emit event which will be consumed by user's device, or rather mark it as an API. Okay, so this API will again push it to the user's device. That will be more organic design to say. So as you can see, like, the design looks quite simple, but what we did was, instead of writing drawing all those boxes in the first place, we broke the system into very granular modules, and then we have come into this conclusion how the whole system would look like. So additionally, the leaderboard service can also have a raw storage over some time. Like, what we can do is, all this data that we are having over here, we are storing it into the Cassandra, right? But we can try to store that the states in some kind of a some kind of a Cassandra DB sort of a thing as well. So or S3 per se, like in case of our archival, like minute archival purposes, that what in a given point of time was my top 10, something like that. My storage also can be like, we can power our storage to answer those kind of questions. So what are the key takeaways? Like, all the design that we have done, so what are the key takeaways for you regarding the final design? So RDBMS dies at scale. Okay, RDBMS dies at scale when we are writing at I'm just not putting any number, but suppose something like a 2 million data per seconds. Okay, data per second in a single table. Things like row locking and stuff might happen here. Okay, so then there comes something like NoSQL. So NoSQL helps us with the scalable lookup, and Cassandra have a very important feature which we can leverage here, is fast partition scan, and that are perfect for fan outs. Then we are going to use Redis for our actual match day storage, and Redis with sorted sets. If we are using sorted sets, all the queries or all the comments in the Redis that we discussed, we will be able to use them. And all of these are being powered by together with Apache Flink. Okay, now here we can actually conclude our video, but I just want to push it a little further. If you are just looking for the overall system design, it's okay. But if you are going for like a AWS specific design, suppose you are in your organization have to do it using AWS mostly, then how you are going to do? Okay, so um, what are the components? Like, let me write it in this way. Sorry, I think I messed up something there while editing. Yeah, so AWS components which can help us to design this. Okay, so what are the AWS components which can help us to design this one? So um, the first because we need those APIs. So of course the API gateway we are going to need. Okay, and we are also going to need like we can leverage AWS Lambda. So the advantage of Lambda function is it scale in a serverless way. So serverless of course is a misnomer, but there is a service instance somewhere behind the scenes. We don't have to worry about it. That is what serverless is. It allows auto scale without needing us to worry about the behind the scenes server management. So now take this use case of scoring like the scoring the point for a cricket event. What exactly is going to happen? Okay, so there is a cricket match. That cricket match will take it to the game service, and game service will publish it to the API gateway. Then instead of our Apache Flink job, we can actually use our AWS Lambda. So whatever the architecture we have done so far, instead of having this two part, we can actually think of doing it using AWS Lambda. So Lambda of course will not work perfectly in a 10 million or 20 million scale user, but this is something, if we at all have to do it for like 10,000 or 20,000 users, we can actually replace all these two, both of them, and uh, use use AWS Lambda for this. And for our storage engine, this archival, this raw storage purpose, we can use DynamoDB instead of Cassandra DB. Now um, now in this context there are few things, like the leaderboards service suppose request the top 10 users via API gateway. Lambda will retrieve it from the Redis, because AWS also have this AWS Redis cache which we are going to use. So most of the thing will be as it is, but what the part that we can actually replace is this Apache Kafka, this Apache Flink, and our the database with Lambda and DynamoDB respectively. Okay, so as you can see here, like we are having a dual data storage, Redis sorted sets for the real-time leaderboard and DynamoDB for the persistent storage. Okay, and it is a serverless architecture. API gateway will be able to manage like 100 k plus connections during the peak. And in our example scenario flow, one of the problem that we might get into AWS based approaches, it might struggle with extreme scale like 10 plus million user. For production, I would say a scale of a Dream 11 or this My 11 Circle, those kind of apps, having Flink plus Cassandra plus Redis is a more robust design. That's the video guys, and that's the conclusion. Thank you very much. This video has gone really long. I understand like this is around like 1 hour 10 minutes or so, but uh, oth- otherwise there was no way to converge into this design. I could have just draw a few boxes and wrap it up in a 8-minute video like in few other YouTube videos the way it is being done, but I think many of the nuances or the intricacies would have been missed. So thank you very much again. If you have made this far, I think you have done a great job. I will try to come up with another video next week. And in case you have any questions, please do write it in the comment section. I keep on addressing the comments on a regular basis. Thank you so much. Have a great day.